Here's another method for solving the system of equations that's equivalent as the substitution method, in that it will solve any of these types of equations no matter how bad the x and y values get. I'm in 4.3. I'm grabbing problem number 14 to start. First thing I'm going to do is rewrite the equations. So I have x minus y equals 4, and then x plus y equals 8. First thing I'm going to do is add the two equations together. As long as you do the same thing to one side as the other side, you're good. So I'm going to add these two things together, and notice what happens. The negative y and the positive y will cancel out, but I will get 2x. And then the 4 and the 8 you'll add together to give you 12. And then I'll divide by 2. And then I'll get x equal to 6. That's half of my answer. Now I'll go ahead and rewrite the equations again. This time, in the first set of equations, I eliminated the y's. They went away when I added this together. This time I would like to eliminate the x's. So if I just had a negative in front of that x, everything would work out well. Well, instead, I'm going to multiply this second equation by a negative, or -1 if you will. Don't forget to apply the negative to each and every component inside the parentheses. So what this gives me then is I get x minus y equals 4, and then I get negative x minus y equals -8. And now I'm going to add them together again. This time I will be able to eliminate the x's. They'll disappear when you take plus and minus x. But this time I'll get -2y. And when I add -8 and 4, I'll get -4. I'll divide by -2. And so I'll get y equals 2. So that will give me my answer. X is 6, y is 2. Now, I don't know that I've gone through the effort of actually checking one of these, but they do check out. If, for example, I replace the x with 6 and the y with 2, well, 6 minus 2 does give me 4. But it's got to work in both equations. So now if I replace x with 6 and y with 2 in the second equation, well, 6 plus 2 does equal 8, so it does check out. For this next example, I see that the 5 y's will cancel because one is positive and one is negative. Let me rewrite the equations to work with them. -9x plus 5y equals -9. And -9x minus 5y equals -9. So the first thing I'll do is add these equations together, and you'll see that right off the bat the y's are eliminated. The x's, though, I'll get -18x. That will equal -18. And then I'll divide by -18 to get x equals 1. Now on the other hand, if I want to eliminate instead the x's this time, let me rewrite the equations. To eliminate the x's this time, I am going to multiply the second equation by -1. That way I'll have a -9x and then I'll have a positive 9x. So let me go ahead and rewrite the equations with that done. I don't recommend you try to do this all at once. I recommend rewriting the equations. For the second one, I will get positive 9x. I'll get positive 5y, and I'll also get positive 9. So when I do add these together, the x's do of course cancel, and I'll get 10y equals 0. Divide by 10, divide by 10, and y equals 0. So my answer is 1, 0. Now for number 24, I see that nothing will cancel when I add right away. So I've got to make some things work. I can see that if one of these y's was positive, then I could easily cancel out or eliminate the y's. So let me rewrite these equations. And I'm going to multiply the second equation by -1. So that gives me, for my pair of equations, 6x minus y equals 4, and negative 9x plus y equals negative 10. Don't forget to apply the -1 to all three components. And now I can add them together. I end up getting negative 3x equals negative 6. I'll divide by negative 3. And I'll get x equals 2. Now to eliminate the x's out of this thing, let me come back to the equations again. 6x minus y equals 4, and 9x minus y equals 10. Now unfortunately, these don't even start with numbers that are compatible for this process. So the easiest way to make this work, if I take this 9 and multiply it to the first equation, I'll start with a 54x. Then if I take this 6 and multiply it to the second equation, I'll also get 54x. But I need one of them to be negative and one of them to be positive. So the easiest way to do that is to multiply the first equation by 9. Where am I getting this 9? Well, the 9 is the coefficient in front of x on the other equation. And then I'll multiply the second equation by negative 6. This way I'll have a 54x and a negative 54x, and when I add them together they will cancel. Let me write them. 54x, don't forget to apply the 9 to every single component, so I'll get minus 9y equals 36. On the other hand, down in the second equation I will get negative 54x, which is exactly what I wanted, plus 6y, and that's going to equal negative 60. And now let's add these two things together. This time, as I mentioned, the x's are absolutely eliminated. For the y's, I'll get negative 3y equals, it looks like, negative 24. Divide by negative 3, divide by negative 3, and I will get y, or is it y? Yes, y equals 8. And so my answer is 2, 8. So far all of these could be done by graphing, so I hope to find some more complicated ones as we move along. Now in this example, these have not fit the format of the other ones, so I'm going to immediately rewrite these equations in the way that the other ones were done. That means I'll have x and y on the left, and I'll have my numbers on the right. So for this first equation, I'll rewrite it as x minus 2y equals negative 1. I got that by subtracting the 1 off of that one. And then over on the second equation, I'm going to add 11y. So I will get 12x plus 11y equals 23. Now, really nothing is compatible for doing anything, but I'll tell you what I will do. I can wipe out the x's by first multiplying the first equation by negative 12. That way, when I do add them, I'll have a negative 12x and a positive 12x. Well, these equations then become negative 12x plus 24y equals 12. And the second equation, I didn't do anything to, so I get 12x plus 11y equals 23. Now let's add them together and see what happens. The x's are eliminated as should have happened. Then I'll get 24y plus 11y will be 35y. And over here, 12 plus 23 also happens to be 35. So I'll divide by 35, I'll divide by 35, and you'll get y equals 1. Now let me have my equations again. This is more complicated. Here, to wipe out the y's, one of them's negative and one of them's positive. So I've started out good there. I can, though, if I multiply the first equation by 11, I'll get a negative 22y. If I multiply the second equation by 2, I'll get a positive 22y, and then they'll be able to cancel away. So let me multiply the first equation by 11. I don't have to do anything with signs out here because one's negative already and one's positive. And the other equation by 2. So what do I get? For the first equation, I get 11x minus 22y equals negative 11. And then I get 24x plus 22y, and that equals 46. Now let's add them together. Here I'll end up with a 35x, and on the other side, well, I will get 35 also. This shouldn't turn out to be so bad. I'll divide by 35. I'll divide by 35, and so you'll get x equals 1. And, well, that was a very easy one. The answer was 1, 1. Now, in this example, nothing is compatible for being erased immediately. So I'm going to have to work on this whole problem. So in order to start working, let me rewrite this 7a minus 5b. Not rewrite it, but I'm just going to write it again so I can do some work on it. 12a plus 8b equals 8. Now let's start by eliminating the a's. I'll need to wipe out the 12 down here and the 7 up here. So the easiest way to do that is to multiply the first equation by 12 and the second equation by negative 7. That way they will cancel. 12 times 7 is 84. So I have 84a. 12 times negative 5 is negative 60b. And that equals 12 times 24 is 288. Now, on the other hand, down here, negative 7 times 12 is negative 84, so I'll get negative 84a. You notice they'll wipe each other out when I add them together. And then negative 7 times 8 will be negative 56b. And then finally, negative 7 times 8 will be negative 56. Let us add these things together and see what happens. The a's, of course, disappear. For the b's, I get negative 116. And that will equal, it looks like 232. So I'll divide by negative 116. And then b is simply equal to negative 2. That was easy enough. Let me move on to eliminating the b's on my next effort. So I'll rewrite again, 7a minus 5b equals 24. 12a plus 8b equals 8. Now in this situation here, to get rid of the b's, one's already negative and one's already positive, so that's not going to be a problem. I'll multiply the first equation by 8. That way I'll have a negative 40b. The second equation by 5. Let me do these multiplications and rewrite the equations. 8 times 7, that's 56. So I get 56a minus 40b equals 8 times 24, which is 192. And then down here, 5 times 12a will give me 60a. And 5 times 8b will give me positive 40b. And then finally, 5 times 8 will be positive 40. Add these together. I get 116a. The b's, of course, cancel by design, and then I'll have 232. Divide by 116. And here we have a equals 2. So our answer in this case, I'll put the a first, 2, negative 2. Number 36 looks bad just because of all the fractions. What I'm going to do is change these equations by first multiplying the first equation by 6, and I'll multiply the second equation by 7. And then I'm going to forget these fractions ever existed. The 6 is going to wipe out all the fractions in the first equation. The 7 is going to wipe out all the fractions in the second equation. So now let me do the first equation. And remember to multiply the 6 times each and every piece. Start with 6 times 1/3. That's equal to 2. So my equation my system I have starts with 2x. 6 times 1/2 is 3. So I have plus 3y equals, and then 6 times 5/3 is 10. For the second pair, the 7 will just wipe out all these denominators, and I'll get x minus y equals -1. Now, I'm going to forget that the initial equations ever existed, and it's like I've been given this as my problem. So this is what I'm going to work with. So with that in mind, if this had been given to me in the book, the first thing I would do is rewrite the problem. And what I'm going to do is first wipe out the x's. So it would be nice if on the second equation I had a -2x to begin with. Well, I'll multiply -2 times the whole equation. And that way, the first equation did not change here. 2x plus 3y equals 10. But the second equation, I get -2x plus 2y equals -2 times -1 is 2. And let's add these together. It looks to me like I'm going to have a 5y equals 12. And then divide by 5 to get y equals 12 over 5. So there's half my answer. Now let me rewrite the equations again. This time I'm targeting the y's for elimination. Now, one y is negative and one y is positive, so all I need to do is multiply the second equation by 3, and I'll automatically have a -3y. When you add it to the 3y, they'll of course cancel. So I'll rewrite my first equation again. 2x plus 3y equals 10. Second equation is 3x minus 3y equals -3. And so I'll get 5x equals, the y's disappear, 7. And so x equals 7 over 5 when I divide by 5. So here's the first one of my examples that could not have been done on a graph. My answer is 7/5, 12/5. Now on this one right here, I'm not going to even bother to try to do this by elimination. I will tell you why. Y is equal to positive 18x. Well, look at the first equation. If I take and replace y with a positive 18x, those will cancel out and I'll get 0. So let me go ahead and take this and plug it into the first equation. The first equation will then become -18x plus y all over 2, and that equals 7/2. When I replace y with 18x, I'll get -18x plus 18x all over 2 equals 7/2. Well, here then, the 18x's cancel, and I get 0 over 2 equals 7/2. Well, 0 over 2 is 0. And hopefully you would not recall that when you get a false statement like this, there is no solution. So the point of this one here, I thought about doing it with elimination. The only thing is that I happen to notice, first of all, it's not in any kind of form that I would like it to be in anyways. Now, I could have wiped out the 2's by multiplying by 2 in the first equation. It's just I happen to see here that if I plugged in that 18x, I would get a 0 here. It will wipe that out really quick. So I hope to impart to you some sort of an idea that you don't just go about mechanically solving these without any thought. If you do think a little bit, many times you can save yourself a lot of effort. This is a very fast way to do the problem if you just notice that you could take this and throw it in there. So I wouldn't have recommended elimination for this type of a problem. However, it would still work. You would just have to multiply the first equation by 2, and the second equation you'd have to subtract off the y. Now, number 42 looks bad, I guess. Let me first start by rewriting it. I'm going to have 0.1x plus 2y. I'm going to subtract off the 0.2. So I have a negative 0.2 over there. The second equation, I have negative x over 4 minus 5y equals 1/2. I think to eliminate all fractions, and I can even eliminate all the decimals if I want. How can you eliminate a decimal that is just 0.1? Well, I can multiply it by 10. That will move the decimal to the right one place. On the second set of equations, I can multiply that by 4. That's the LCD. Then what I'm going to have are a pair of equations that no longer have decimals or fractions in them. So let's start with the first one. 10 times 0.1 is just 1, or 1x is just x. 10 times 2y is 20y. And then 10 times negative 0.2 is negative 2. Now down here, 4 times negative x over 4 is negative x. 4 times negative 5y is negative 20y. Oh, look at this thing, isn't this cute? And then 4 times 1/2 will give me 2. When they add them together, you can see all of this stuff wipes itself out, and so does the other side. Well, if you remember, this is not a false statement, this is a true statement. So this just means there are infinitely many solutions. That's because these two equations actually graph the exact same line. A problem like this one might be good for substitution because you can just add 9y and then you get x and y in there. Although you'd be dealing with fractions, which I'd prefer to hold off until the very end. Instead, what I'm going to do is multiply this second equation by 6. This way I can wipe out the fraction. And I won't do anything to the first equation, so I'll leave it as 8x minus 9y equals 0. But the second equation, when I multiply it through, the 6 will wipe out the 6 down here, and you'll get 2x minus 3y equals negative 6. And now these are the equations that I'm going to work with. So I'll first wipe out the x's, so let me rewrite this. I think I put a 9x, didn't I? And I'm not doing anything yet. Now to wipe out the x's, I can simply multiply the second equation by negative 4. That way I'll have an 8x and then I'll have a negative 8x. So I get 8x minus 9y equals 0. Negative 8x. Negative 4 times negative 3y will give me positive 12y. And then I will get negative 4 times negative 6 will be positive 24. When I add them, then the x's will go away, of course, and I'll have 3y equals 24. Divide by 3, and you can get y equals 8. So there's half my answer. Let me rewrite these again. 8x minus 9y equals 0. 2x minus 3y equals negative 6. And now a similar kind of thing is what happened last time. If I could change this negative 3 to a positive 9, everything's good. So I'm going to multiply the second equation by negative 3. The reason for is that will give me a positive 9y here. When I add to the negative 9y, they'll go away. So I have 8x minus 9y equals 0. And then I have negative 6x plus 9y equals negative 3 times negative 6 is positive 18. Add these together, and I'll end up with 2x equals 18. Divide by 2, divide by 2. X equals 9. And so my answer is 9, 8.